Hello and welcome. In this module, we will discuss problem detection and resolution as a domain of Agile practices. Problems are an inevitable part of any project. Proactively identifying and resolving problems is crucial. Pushing ahead hoping that the problem will go away can damage the project in terms of both time and cost. Diagnostic activities such as measuring cycle times and trends can help spot problems before they arise, while tools such as escaped defects identify issues that have already occurred. Cycle time is the period of time taken to complete a task, such as developing a feature or an item on the backlog. Cycle time and work in progress, or WIP, are closely related because large amounts of WIP can create bottlenecks. If any problems arise, there can be large chunks of rework, which increases cycle time. Therefore, it is important to limit WIP. Throughput refers to an amount of work that a team is capable of doing. Using WIP and throughput, the cycle time can be calculated. Cycle time equals WIP divided by throughput. The rate of cost of change is proportional to the time taken to resolve an issue. This is because work built on top of defects may need to be undone or reworked. Despite best efforts, occasional defects might slip past quality control processes and make it to the customers. Escaped defects occupy the top spot in a cost of change graph. Tracking escaped defects on a graph can help evaluate and improve quality control processes. Problem detection and resolution is highly dependent on the quality management practices implemented in the project. There are several quality standards and practices that teams can utilize to ensure quality. Ensuring testing is a part of each iteration, and fixing more than 3/4 of defects in the next iteration leads to high quality management. The quality assurance team should also work with developers and business requirements to get a thorough understanding of requirements. Tests should be automated as frequently as possible. Defects should be considered as fixed only when business representatives accept that they have been fixed. Identifying and accepting failure modes and looking at alternatives to overcome those are essential to problem detection and resolution. Alistair Cockburn suggests establishing and encouraging the adoption of a standard way of working while still including scope for tolerance and forgiveness. He also says that creating a concrete representation of the final solution will help overcome failure modes. Another step to take is to alter or modify an existing design that can act as a framework for the solution instead of starting from scratch. Further, assigning work based on the personality types of different team members and attracting and retaining the best talent are effective ways to overcome failure modes. Providing quick and continuous feedback also helps a good deal. Let us now look at variance and trend analysis. Variance is the measure of how far an actual outcome is from the expected outcome. Although variance is normal and acceptable within limits, it is important to know how to manage when variance is beyond acceptable limits. Common cause variation is the difference in work output in a daily or weekly scenario caused by normal factors. Special case scenarios refer to variation due to new developments or special factors. While dealing with variances, managers might confuse common cause variation with special cause variation and vice versa. Common cause variation is normal and accepted and does not require any intervention, while special cause variation is due to an underlying issue that needs to be addressed. Trend analysis gives project managers an indication of potential issues before they have cropped up. Lagging metrics, such as the proportion of budget that has been utilized, provide insights into things that have already occurred. Leading metrics provide information about things that may be happening or about to happen in a project. Control limits can provide warning signs about problems that may occur. Task boards are a good tool for team enforcement of control limits because they restrict the team from undertaking too many tasks. And using continuous integration techniques, developers commit new and modified code into the code repository whenever possible. This mitigates the problem of multiple team members making changes to obsolete code, ensuring that only the latest code is worked on. This avoids any compatibility issues. Now let's look at risk-based spike. A risk-based spike is an exercise during which a problem is analyzed. An isolated experiment is performed to find a solution for a problem. The problem is eliminated if the experiment is successful. Risk-based spikes are usually used early on in projects that are trying to develop new technologies before venturing too far into project development. Another practice is frequent verification and validation. It is a continuous, multi-level feature of Agile projects. With this practice, it is easier to ensure that the project is progressing according to plan and that there are no errors. Now let's examine the steps involved in problem solving. The first step is to gather data. The data should have a shared view. Several activities such as timeline, triple nickels, satisfaction histogram, team radar, and color code dots can be used to gather data. The second step is generating insights. After data is gathered, the team analyzes and generates insights about the problem before deciding on an action plan. Activities that can generate insights include brainstorming, fishbone, identifying themes, and 5 whys. Deciding what to do is the final step. Using activities such as short subjects, SMART goals, a retrospective planning game, force field analysis, and circle of questions, teams formulate and validate approaches to resolving problems. And with that, we've come to the end of the module. We hope that you've benefited from this video. Thank you for learning with us.